Ever wondered how a robot could follow a complex command like, find the red cup in the kitchen and bring it to the table, without being programmed for every possible scenario? That's the magic of embodied navigation, the ability of AI to interact with the physical world using vision, language, and action. But here's the catch. Traditional systems often tackle each task separately, like a chef using different tools for chopping, boiling, and baking. What if we could unify all those skills into one smart, adaptable model? Enter Uni-navid, a groundbreaking video-based AI model that's rewriting the rules of embodied navigation. Think of it as a universal translator for robots, capable of understanding visual scenes, interpreting natural language instructions, and executing precise actions, all while adapting to new environments on the fly. So how does it work? Uni-navid doesn't just look at static images, it learns from videos. By analyzing sequences of frames, it captures dynamic interactions, like how a robot arm moves to grasp an object or how lighting changes in a room. This video-centric approach lets the model understand not just what is happening, but how things change over time. But here's the real innovation. Uni-navid ties this visual understanding to language and action. Imagine training a robot with a mix of video clips, text instructions, and action logs. The model learns to map phrases like turn left at the sofa to specific movements, all while generalizing to new, unseen scenarios. It's like teaching a child to navigate a maze by showing them videos of other mazes, explaining the rules and letting them practice, without ever seeing the exact same maze before. The results? Uni-navid outperforms previous systems in tasks ranging from indoor navigation to object manipulation. It handles ambiguous commands, adapts to novel environments, and even recovers from mistakes, like a human would. And it's not just theoretical. The research builds on advances from models like RT2, which bridges web knowledge to robotics, and DreamVLA, which blends multimodal creativity, showing how combining vision, language, and action creates smarter, more flexible AI. Now let's zoom in on another game changer, DreamVLA. This model takes embodied AI to the next level by letting robots predict the future. Imagine a robot that doesn't just follow instructions, but understands them, like a helpful assistant that can grasp, move, and manipulate objects in a way that feels almost human. At its core, DreamVLA is a brainy system that combines language, vision, and robotics into one cohesive framework. It uses a text encoder to process instructions and a visual encoder to see the environment through two cameras, one on the robot's arm and one fixed above. These inputs are then condensed into a compact, mental map, using a tool called the perceiver resampler, which filters out the noise and keeps only the details that matter for the task. But here's the clever part. DreamVLA doesn't just react to the present. It predicts the future. By analyzing motion patterns, depth, and semantic features, like identifying a drawer or a light switch, the model generates rich visual forecasts. It's like teaching a robot to imagine what will happen next, whether an object will slide, how light will cast shadows, or if a door will swing open. This predictive power is powered by three key components. 1. Dynamic regions. It spots moving parts, like a door swinging or a cup being pushed. 2. Depth maps. It calculates distances, turning 2D images into 3D space. 3. Semantic clues. It recognizes objects, a cup, a table, using advanced AI like DNAV2 and SAM. These predictions let the robot plan smarter. Instead of guessing, it foresees what's coming. For example, if a cup is wobbly, the robot adjusts its grip mid-motion. And the results? DreamVLA nails 76.7% of real-world tasks, like picking up objects or opening doors, and crushes benchmarks with a 4.44 average task length. That's 3.5% better than previous methods. The secret sauce? A clever blockwise attention system that keeps different types of info, like movement and depth, separate so they don't confuse each other. Plus, a diffusion transformer that refines action step by step, like editing a rough draft into a polished plan. So what's next? DreamVLA and Uni-navid aren't just tech fixes. They're leaps toward robots that understand their world, not just react to it. Imagine robots that can handle unpredictable environments, from kitchens to disaster zones. The future of AI isn't just about seeing the world, it's about anticipating it.